What if you could take just one picture? Doesn't matter if it's an old photo, a painting, your digital avatar, and pair it with some audio and get a perfectly lip-synced video out of it. And I'm not talking about a little 5-second clip. I mean for an entire speech or a whole song. That's the promise here. That's what we're diving into.
This entire video is being generated from a single static image and a separate audio track like the one I'm recording right now. For years, AI video synthesis has been limited to short, glitchy clips. Long-form, stable video was the goal, but no model could maintain identity and coherence until now. This is InfiniteTalk, a new model that claims to have solved the long-form video problem. Today on Codebreakers, we're putting those claims to the test. We will build a workflow, stress test the output, and determine if this is the breakthrough that finally makes digital humans a practical reality.
All right, so first things first, let's really break down what InfiniteTalk actually is, and maybe even more important, what makes it so different from everything we've seen before. Okay, so at its heart, InfiniteTalk is what we call an audio-driven AI. And that's just a fancy way of saying the sound is in charge. The voice, the singing, that's what makes the person on screen move. You can feed it a single picture or even an existing video, but the real magic, well, it's right there in the name. It can create these super high-quality, perfectly synced videos that are, in theory, infinitely long. And to really get why this is such a breakthrough, you kind of have to know how the old models worked. See, they were basically just copying and pasting expressions, and they were stuck with this thing called a sliding window, which meant every few seconds, the AI would have to kind of reset itself. This created this really annoying visual flash or stutter. InfiniteTalk, it doesn't do that. It's generating the motion from scratch based on the audio, so you get this clean, smooth video for as long as you want.
The official implementation is hosted on the MeiGen-AI GitHub repository. All pre-trained models are available on their Hugging Face page, also under the MeiGen-AI organization. To establish a performance baseline, let's first review the official demonstrations provided by the developers.
InfiniteTalk revolutionizes digital human creation by enabling unlimited length talking video generation. No more time constraints. Here's how it works. First, upload just one image plus an audio clip, and we generate perfectly lip-synced videos of any duration. Second, if you provide an existing video plus audio, we go beyond lip movements to reanimate full-body gestures, making characters truly expressive. Our ultimate mission to create virtual humans indistinguishable from real people with eye contact. Natural micro-expressions and fluid motion that pass the uncanny valley. Whether you are producing educational content, AI influencers, or next, Gen customer service avatars, InfiniteTalk delivers cinematic realism at scale. Join us to pioneer hyper-realistic digital beings that transform human-machine interaction. Let's build the future together.
So we will now cover the model downloads. For this ComfyUI workflow, we'll use the converted Safe Tensors version. While the official PyTorch models are on the MeiGen-AI Hugging Face page, these are available on Kijai's One Video Comfy repository. The InfiniteTalk subfolder provides two primary bundled model options. For a video focused on a single person, you can download the file One Video InfiniteTalk single.safetensors. For a video featuring multiple people, download the file One Video InfiniteTalk multi.safetensors. You may want to download both of these files and keep them. For those of you that are familiar with Comfy, then you simply put this model in your Diffusion Models folder. I have created a WAN 2.1 subfolder. This is where I keep the WAN 2.1 models, and this is where I'm placing the InfiniteTalk files. For those of you that are new to ComfyUI, it is a node-based graphical user interface for building and executing generative model workflows. While it is most commonly associated with Stable Diffusion, its flexible architecture allows it to run a wide variety of models via custom nodes. It visualizes the entire generation process as a flowchart, offering granular control and a clear view of the data flow. If you want to learn more about getting started in ComfyUI, please go back and watch this video where I show you how to simply install ComfyUI onto your system. But with recent updates to ComfyUI, it's really easy to get started. The base checkpoint model we're using here is the WAN 2.1. The core principles and settings are functionally identical to the WAN 2.2 model, which I cover in depth in a separate dedicated tutorial. The WAN 2.1 is a single model file. You can download the model files from the comfy.org WAN 2.1 ComfyUI repackaged repository on Hugging Face. There you will find all the model files in their different precisions. Today I'll be using the WAN 2.1 image to video 720p 14 billion parameter FP8 E4 M3 FN safe tensors file. It's a 16.4 GB file and it's a simple FP8. This is half the precision as the main unit model, which is over 32 GB. This is a very VRAM intensive workflow, and I'll be using this model for today's demonstration as this is the model that most people will be able to run. For higher end graphics cards like the 4090 or the 5090, you could try using the FP16 version. But be warned for long generation times, and through my testing you will see that the FP8 version gives quite good quality and you can always upscale. So download the FP16 version or the FP8 version, whichever one you're using, and make sure it goes into your diffusion models folder. This workflow depends on several foundational models. First, a base checkpoint model is required. This is a standard stable diffusion model that creates the core image. The InfiniteTalk workflow works on the WAN 2.1 model. Second is the clip model, which functions as a text encoder. It interprets your text prompt and converts it into an embedding that guides the image generation process. The clip model that we need to download is the UMT5XXL. And third, the VAE, or the variational autoencoder. Its purpose is to encode the image into a compressed latent space where the diffusion process occurs, and then decode the results back into the final visible image. For our workflow, we need the WAN 2.1 VAE. Additionally, we are loading a LoRA. LoRA, which stands for low rank adaptation, is a small model that fine-tunes the checkpoint, allowing us to modify the output to achieve a specific style or concept with a much smaller file size. The LoRA we'll be using on our workflow is a performance LoRA. We'll be using the LightX2V text-to-video 14 billion parameter. I've been using the rank 256, but you can try using a rank 64 or 128. So all links are in the description, but you download these files and place them in the right folders. So we'll just quickly run through the folder placements. Your main WAN 2.1 model will go into your diffusion models folder. Your InfiniteTalk model will also go in your diffusion models folder. You can create subfolders if you want, but the subfolders must go inside the diffusion models folder. Your UMT5XXL FP16 or FP8 version will go inside your clip folder. Your WAN 2.1 VAE.safetensors file will go inside the VAE folder. Our LTX LoRA will go inside the LoRA folder. We will also need a clip vision model. This is so that the model can see and interpret a loaded image or video. In the WAN 2.1 Comfy repackaged repository, you will also find the ClipVision-H SafeTensors file. Download the ClipVision-H SafeTensors file and place it in your ClipVision folder. And that's our model placements done. Let's move on to the workflow. So I've left a link in the description to the Codebreakers.site website where you can go and grab this workflow, download the JSON file and drop it onto your ComfyUI canvas. So let's deal with the custom nodes. So after dropping the workflow onto the canvas, if you see any red lines around your nodes, it means you are missing some custom nodes. Go into the manager and install missing custom nodes. After the installation completes, restart ComfyUI and refresh your browser. After restarting, your custom nodes should now appear. If for any reason that it doesn't, then you need to update ComfyUI and update all custom nodes. Go into the manager and update all. Restart and refresh. So let's just take a look at this workflow. This is an image to video workflow. There is also a video to video workflow, but we won't be going through that here. Notice the resolution master node that I've placed here. This allows us to set the final generation quite easily. It connects directly to the WAN video wrapper's InfiniteTalk node. We'll talk more about this node a bit later on. So we want to make sure all our model files are selected in our loaders. So in your WAN video model loader, make sure you have the files selected, either the FP8 version or the FP16 version. I'll be using the FP8 version for this demonstration. Pay attention to my settings because these are really important. Next, in the WAN video T5 text encoder loader, make sure you have the UMT5XXL loaded. I'll be using the FP16 version here. Notice in the one video block swap, I'm using 20 blocks to swap. Here you substitute your VRAM for your system RAM. It will increase the generation time but save on VRAM. So if you get out of memory errors, you can try to increase this. Next, make sure your LiteX LoRA is selected in your LoRA loader. And notice the strength has been set to 0.8. This I found to be optimum, but please feel free to play around with your own setups. Next, make sure your VAE is loaded into your VAE loader. Now I'm using the FP32 Safe Tensors version. If you have any VRAM constraints, you can go ahead and try the FP16. And this workflow uses a load WAV to VEC model. Now this model downloads and caches when you first run the workflow, so it's not one that you need to download. But this Tencent GameMate model handles both Chinese and English, and the InfiniteTalk model doesn't seem to work with any other model. But it downloads through the WAN video wrapper onto your computer when you run the workflow. Now take a look at these settings. In the InfiniteTalk node, I have the frame window set to 121. You can set this to 81 or lower if you have VRAM constraints. This is like the context options node. This will chunk the video into 121 frame chunks. Below this you will see the motion frame. This is the size of the overlap between each of the chunks. The larger the overlap, the smoother the transitions, but the longer the generation time. The larger the frame window size and the motion frame, the more VRAM you consume. Lower these to lower your VRAM. Here it's a case of finding your sweet spot. Next, let's look at the sampler. Here the steps are set to 4, the CFG is set to 1, the shift is set to 11, and I'm seeding on a fixed seed. You can change the seed if you want. Force offload is true, and the scheduler is always flow match distill for this workflow. And the denoise strength is set to 0.9. I wouldn't mess with that, but you can try. This I found to be the sweet spot and not get decoherence on long generations. And the last few settings just leave alone. The start step is 0, the end step is -1. So a little bit of information about the resolution master node in the workflow. I've included it purely for convenience, as it allows us to set the output resolution for the entire process from a single central point. The width and height values you set here are fed into all the necessary nodes, ensuring consistency. Now a critical point to be aware of, not all resolutions will work. If you run the workflow and encounter a tensor mismatch error, the cause is almost certainly the dimensions you've set in this node. The fix is simple. Come back here and change the resolution. As a rule of thumb, AI models often require dimensions to be multiples of 16 or 32. If you're having issues, try a different standard resolution or values that follow this rule, and that should resolve the error. So we've selected all our models, we've configured the workflow, we've set our resolution. Now go ahead and load in an image. So I've selected this image to animate for a music video. So I will load in an audio soundtrack. So I wrote this song with the help of ChatGPT to create the lyrics. Then I imported it into Suno, where I've done the musical composition for the song. I've trimmed a 30-second clip of that audio for testing and also as a demonstration here. You can create your own musical compositions and try it yourself. And just to be clear, I'm not sponsored or affiliated with anyone, so you can be guaranteed of an honest review. I use tools that I find work well. So anyway, let's run this workflow. And first generation always takes a while. Some of these generations have been taking me more than half an hour for over a minute long videos. And here's the output from that.
Somewhere beyond the signal, voices start to climb. Drifting across the distance, softly keeping time. Blue river, endless and wide, carry my song through the night.
Now please, I'd like to hear from you in the comments what you thought. I'd be really interested to know if you feel that this video composition is usable in a professional workflow. You can quite easily see that the characters in the background are failing to animate correctly. This is quite a static composition, and that happens from the image to video workflows. Now, the video to video workflow, you can get a dynamic composition and change the lip sync. Here's a demo of that, even though I won't be testing that workflow here today.
Somewhere beyond the signal, voices start to climb. drifting across the distance, softly keeping time.
So that control video I loaded was from the InfiniteTalk GitHub pages to get past any YouTube copyright issues for the purposes of this demo. I resynced it with my own audio, but if you head over there you can see the examples. So here's a few different generations I've done using different styles.
Bananas! You spent all that time building this super fancy AI that can talk forever, and you didn't think to teach it the important stuff? Like how to peel a banana without squishing it? Or how to stop humans from clicking, "I agree to the terms and conditions" without reading them. Come on! I mean, sure, it can sing, it can rhyme, it can probably beat me at chess. But can it find my left sock? No. Can it explain why printers always break when you're in a hurry? Absolutely not. Look, I'll tell you the truth. Infinite talking is impressive, but until it can order me pizza, do my taxes, and stop me from accidentally replying all on work emails, I'm not worried. For now, the monkeys still rule the jungle. Okay, I'll stop talking. Wait, no I won't. I'm infinite too.
Break it down, crack the code, the lines of truth and overload. Keys unlock the hidden streams, decode the future, chase the dream. Digits in the dark, patterns in the night. Symbols on the screen start burning bright. Every cipher's got a voice, every lock's got a key. I'll break the silence, set the knowledge free. From turn to the circuits in my veins, I'm surfing data waves like electric trains. Infinite talking, the signal flows. I bend the syntax, everybody knows. Break it down, crack the code, lines of truth and overload. Keys unlock the hidden streams, decode the future, chase the dream. Scroll the lines, let the rhythm unfold. Stories encrypted, secrets retold. Not magic, it's logic, the path that I chose. Forever a code breaker, that's how it goes.
So I created the lyrics for that, the music composition and the video, all while having breakfast in about half an hour. As you can see, the lip sync isn't 100%, but it's not bad. I probably will try to tweak it a bit more and see what I can eke out of it. But I'm not leaving the day job quite yet. I've left a copy of this workflow on the Codebreakers site. Have a play around. So I hope that was interesting. And that's it. A complete end-to-end workflow for generating talking head video using the InfiniteTalk model in ComfyUI. The results demonstrate its capability for producing long-form synchronized lip movements. If this analysis and workflow provided value, please consider subscribing to the channel. My goal is to consistently deliver in-depth tactical guides on cutting-edge models. We have a significant number of new models and advanced workflows in the pipeline, and we will be breaking them down in upcoming videos. Thanks for watching and have a great day.